C and PE. Then you can see between PE and others where it is filled. So that is why when you have a multicolor experiment, it's very important to have single stain controls to prevent the spectral overlap and to correct the compensation. Okay?
So the compensation is always...
always they have to be controlled by this. So, whether it is between FL2 and FL1, if it's FITC and PE, you will be adjusting these two numbers. Now I'm putting PE. I'll show you. That's why I made this experiment. So that you understand, because your one color experiment, you will not understand anything that's present or not. But this makes you understand the whole concept.
Yeah. So the compensation is always 1, 2, 3. So between 1 and 2, 2 and 3. The overlapping.
It is whatever detector you're looking at. Now just sit here. Pause, restart. So this is my PE. See how bright it is? This is my negative for PE. This is my positive. Negative and positive. So now, if I change this, this is PE, which is my FL2, right? FITC is FL2. I'm sorry, PE is FL2. Because FL1 is always FITC.
Oh,
FL2 is always PE. FL3 is always here. You label.
Oh, that's right. I would label.
And then FL4 is always APC.
Okay.
Right for you here. FL1, FITC, FL2, PE, FL3, per CP, FL4, APC. Okay? So if previously I was looking between, I put FITC, so the problem is most likely between this and this. You can see from the screen. Okay, and now I have put PE. There is no overlap, but if I change this, look at this value. See, it's all overcompensated. It just went inside. And instead, I'm just gonna go. Pause, restart. Pause, restart. There we go. See? I just want to show you. Pause, restart. So now my PE is being, because I gave you the calib reading, the calibration file. So everything looked very perfect. So, but I'm changing it to show you that when do you need compensation. Now in FITC, your PE is being detected. Your PE signal like this. I decreased it, so that's why it just, came now into the FITC. So now what's happening is PE is filling in FITC. So what I'm gonna, so now this is, because the opposite situation of what we saw. Now it will be FL1 minus FL2. Because previously PE was filling into FITC. So you did FL2 minus FL1. But now your FITC is filling, your PE is filling in FITC.
This
and
is
you need to
supposed to be PE.
Yes. And then you see here, you keep watching here, I'm doing FL1 minus FL2. Look at the population. Now the population is fine. Because this was being detected here, and that's a very big problem because that's PE positive. It should not be in FITC channel. So I compensated it using these numbers to get it right. So I mean, you can tell because, if this is your FITC, FITC positive. PE, PE positive. But instead of being here, if it is here, there could be a problem. And especially the way it is meant. So you will say pause, abort. Now let's look at the third color. Is it making sense?
Yeah.
Then you take your per CP and you go acquire. This is perfect. It looks very good, per CP. But this is between 4 and 3. Now it has nothing to do between You know, it can be a problem between 2 and 3. You know, this is between 2 and 3, but usually this generally we don't change much, but depending on the experiment, anything can. So I'm just gonna try to, you know, this is 3 and 4, okay? If I do this, not much of a problem. And instead look at this. Okay, this is 5.9. Just a little bit change, but not too big, because per-CP basically is not giving you that much spill. So even if you adjust those numbers, that is between 3 and 4.
Okay,
Between
I see.
3 and 4. Okay, so what I put it, I'll just go back and then put it. So this is just, you know, you can change these values to see that if it is just, you know, making any sense, or if there's any compensation issue or not. But in your case, to begin with, the one color is not going to be a problem.
Yeah.
It just should be okay. Yes. So this is how you can see whether it is FL1 between FL2, FL2, FL3, FL3, FL4. So you check everything, whatever number of colors you're using.
Okay.
Then we throw APC. Pause, restart. See, this is APC. Okay. And if the voltage is,
wow.
yeah, so it's very bright. So if you
Yes.
want, you can decrease the voltage a little bit. Pause, restart. See, this is fine.
Yeah.
And then if I showed you, so this 4 and 3 you want to play with. FL4 and FL3. So let's see what happens. FL4 and FL3, okay? So this is 6.9. Pause, restart. Nothing happens there. So one good thing is, because there is no spillover between.
Yeah, this
is on the
one seems to
red
be
color,
right.
and this is, so it's pretty stable.
Yeah.
So you don't have to worry.
Yeah.
So only the problem we saw was between these two,
Okay.
FITC and PE.
Right.
Okay.
Yeah. Yeah, these two are pretty.
They are pretty good.
Right,
Nothing
right,
is changing.
Right, yeah.
So I just tried different ways to
Right,
just, you
right.
know, show you that if you have 4 different colors, 3 different colors, how should you be concerned?
Right.
And there's nothing that you have to memorize here, because it is just about, it's showing you which
Right,
two
right.
parameters you should work on. FL4, FL3, FL3, APC and per-CP. Per-CP and APC. Per-CP and FL2, which is PE. PE, and then this is per-CP. Generally that is 0, because PE and per-CP, not much of a problem, unless the antibody is different. So,
Yeah, yeah.
and it depends with the antibodies also. It is not that what I stain should be perfect for everybody, because your antibody would be different. The fluorescence parameter you're using could be different. It could be behaving different. It could be spilling into the next channel. So you have to make sure that you correct the compensation. Once you know how to do it, you can just play with that stuff. Okay. And now, as you said, you know, I think this system is perfect for me. I have optimized my instrument. Now I'm just gonna go and say pause, abort, set.
Uncheck and then I'll save the data.
Yes. Now I'm just gonna go ahead, and then you will see this number will change.
Okay.
I will do this, and I will say, oh, before that, I want to show you this.
Prime.
Yeah, I'm just like, you know,
Oh.
it's monkey sample, sometimes you never know.
I
Okay.
see.
Now I want to tell the instrument how many events to acquire, because I cannot keep looking. So for that, one thing is I just go to acquire, and I say acquisition and storage, fax caliber, accept all events. Everything which is processed, I want you to accept. But when should the acquisition stop? Processing means everything should be on the first gate, should be collected.
Okay.
But I want the acquisition to stop when my in-gate, the target amount reaches. Suppose Hong said, I want in this gate only 50,000 events.
Okay.
So 50 plus it could be another 150 with all this. I don't care. But I need at least 50 in this. So the instrument keeps working hard. If you don't put this, if you say acquisition will stop 10,000, so including everything is 10,000, so you might not get the population you're targeting for the number you're looking for. So it's very important to tell the instrument, what do you want in your gate? How much do you want? More or less? So then it will keep pushing for that many events irrespective of what it has other than the gate. So I'm just going to say, go ahead.
How do I know which gate this is?
This is because I will show you. Because I'm saying here, since I already made a gate, it will show.
Oh, R1.
Okay.
R1.
And I will say, okay, 10,000 events for today is fine.
Okay.
But still, it's only the acquisition will stop when in that gate that many events, but the data file will contain everything you have recorded. Because when you analyze the data in Flojo, you have everything to play with.
Right. Yeah.
Okay? So, and then, so I say, okay. Now the next thing is go to counters, because you want to keep track of your stuff which is going on. And open up this, the plus sign, and accept all events. Here, collect, because you already gave G1, and then it's accepting everything else. So here it will give you total number of events which are being recorded, events per second. It gives you this information which you can look at the screen. Oh, my sample is too dilute, my sample is too concentrated. It will tell you the events per second.
Okay. This counter is just for the visualization?
This is just for visualization.
Okay, not for...
No,
I see.
no.
Okay.
That is why I pulled it right now.
Okay.
This is what you need for recording.
Okay.
But this is for you to visualize.
Okay, yeah.
And this comes from this window. Acquire
counter.
Okay, yeah, that's what it comes. Now, let me put my, now this is my, these were my single stain controls to correct the compensation. Okay. Now I have my fully stained tube which have 4 colors.
Nice. Okay.
And I say acquire. Sorry. One thing is first I should have and also I need to record these. Actually compensation I'm not recording, I don't want to worry about it. I just record one tube to show you that this number is going up. Okay, I say, and I put the name here, sorry, the sample ID. I call this thing as unstained. Okay, and I say acquire. Okay. It's acquiring.
Okay. Can you change the file name, say unstained.11?
Yeah, whatever, anything you can just change, whatever, you know. So once it reaches 10,000 events, now I can put it on high. Okay. Once it reaches 10,000 in this, it should automatically stop.
I see.
Because we have already given the command, stop. Otherwise it keeps going. And it's telling you events per second.
A lot of cells.
A lot of cells. And see, now it should stop. It's done.
Okay. Yeah.
It's stopped. So you take it. And it says data 2. If you go back just to check. Okay. So if you look at this, so it just shows you that the data is recorded. Okay. And because it says data 1. Okay. So that means you can confirm. Okay. I think no.
Yes, do you know Daniela?
Yes, I sure do know.